In terms of technical characteristics, what do we have in this scanner? Basically, it has two scanning modes, which is a unique feature. It includes the HD mode, which is the high definition mode, and the fast mode, which provides lower resolution for larger objects. We will now separate the characteristics for each of these modes. For the HD mode, the light source is infrared, created by the MEMS system, which is an electromechanical system. The minimum point-to-point distance ranges from 0.05mm to 3mm. Something seems to be wrong with this point, as the scanner console indicates a minimum of 0.1 to 0.25mm in HD mode, rather than the 0.05mm mentioned here. Furthermore, the results of some tests I conducted with the scanner at its maximum resolution suggest that the correct value is most likely 0.1mm, or more likely 0.25mm, as the maximum resolution between points. The capture rate, when performed in motion, is a maximum of 15 frames per second, and the object should be at a distance between 100mm and 300mm. In contrast, in fast mode, the system still uses an infrared laser light, specifically the VSSL system we discussed earlier. The point-to-point distance here is substantially larger. Previously it was 0.05mm to 3mm, and now it ranges from 0.5mm to 10mm, which is quite significant. This means we are considering objects that are much larger to accommodate such a large point-to-point distance. The capture speed in this mode naturally allows for higher velocity, reaching 20 frames per second. Since there is less information being processed by the scanner, the working distance, or the distance from the object, also increases. It now ranges from 350mm to 1500mm, or 1.5 meters, compared to the previous range of 100mm to 300mm. Some features are common to both modes. Regarding alignment, the scanner allows for alignment based on the geometry of the object. This means that objects with intricate designs are typically easier for the scanner to capture. Additionally, it supports alignment using adhesive markers or by recognizing the texture of the object if it is a distinct characteristic of the piece. However, if the object has a uniform texture, such as a painted panel, the scanner may not be able to track successive points and markers will need to be used. In HD mode, the infrared camera used has a resolution of 2 megapixels. In fast mode, the camera resolution is 1.3 megapixels. The cameras used for these two modes are therefore different. The texture capture camera has a resolution of 48 megapixels, which is relatively high compared to current standards. The scanner supports exporting in formats such as PLY, STL, OBJ, and ASC, represents the point cloud positions generated by the scanner, while the others are polygons, usually triangular meshes that form the 3D model. The scanner can also be used outdoors under sunlight. Its weight is between 500 grams and 600 grams, which is not particularly heavy, but also not light for extended use. The software that comes with the scanner, Star Vision, supports both Windows and macOS environments. However, the macOS version appears to be compatible only with Apple's processors. The processor in this Einstar model, featuring 8 cores with a speed of 2.4 GHz, 32 GB of DDR4 RAM, and 2 storage options. A 32 GB eMMC drive likely for cache, and a 512 GB SSD, probably SATA, hence slower. The power brick provided delivers at least 65 watts, allowing for fast charging. The scanner also includes interfaces such as Wi-Fi 6 and USB-C for communication. File transfers are performed via USB-C, as the file sizes can quickly reach gigabytes. While the USB-C type, 2, 3, or 4, is unclear, The recommendation to use a high-speed cable suggests it is likely USB 3 or 4. The scanner includes an internal, non-removable 5000 mAh battery, but allows for extended use with an external USB-C power bank. The AMOLED touchscreen measures 6.4 inches. The scanner uses 10 LEDs to illuminate the object, though not all are used simultaneously. The inertial measurement unit, IMU, provides 6 degrees of freedom, measuring the X, Y, Z axes and their respective rotations. The scanner also has an IP50 rating, meaning it is protected against dust but not against liquids. Keeping the optical systems free from dust is essential for maintaining performance. Some critical data, like precision and accuracy, are not provided in the public documentation. In practice, what is resolution? There are 3 terms and characteristics that are important in scanners. One of them is resolution, another is precision, and the last one is accuracy. These are 3 terms with distinct meanings, and they are often confused. In terms of resolution, what is it? It is the technical limit or the level of detail that the scanner can achieve. For these devices, we are referring to the point-to-point distance it can obtain. The smaller this distance, the greater the detail it can reproduce, and consequently, the higher its resolution. This is the same principle as in photography. Precision, on the other hand, is the consistency in measurements. In other words, when it measures an object or scans it multiple times, the scanner can consistently generate an almost identical point cloud. That is, the distance between points A and B in the same area remains nearly the same. This indicates good precision. In practice, it is essentially this: consistency between measurements. Finally, in my opinion, the most important factor is accuracy. Accuracy is the proximity of the results you obtain from the scan to the actual dimensions of the physical object. In practice, you will scan an object, then measure it using the scanner or on a computer, take note of the dimensions, and compare them to the real object's measurements using a measuring tool like calipers. Simply put, it's the difference between the virtual object and the real one. So, what is the accuracy of this scanner? I repeat, for me, it is the most important of all these points because I use it to perform measurements. I don't know. I don't know this value because I've looked for it and couldn't find it. That said, this value is relatively easy to determine, even if it isn't explicitly stated anywhere. You just need to take an object, scan it, and then compare it to the real measurements. And then we'll have the accuracy that can be achieved with this device. These points were important. It's a pity that this table I'm showing you doesn't include the precision and accuracy. It only shows the resolution applicable to both scanning modes. These 2 technical characteristics, precision and accuracy, which are more specific, would be good to know. The reason I chose the Morocco Mini 2 was precisely because they provided this data, even if only for single frame captures, where the precision is 0.02 millimeters and the accuracy is 0.05 millimeters. I will not state the accuracy I achieved because my measuring instruments are not calibrated, so I could be providing incorrect information. However, this is information that Einstar should have. Regarding the technical characteristics, this is essentially what I wanted to share. Other things could be mentioned, but the video has already reached the 10-minute mark. Next, we will perform a scan and discuss how to do it and the best conditions for scanning with this device.